All right, now we're dividing radicals or rationalizing radicals, which is just saying you can't leave a radical in the denominator. So to get a monomial radical out of the denominator, you multiply the numerator and denominator by the radical. So I multiply the numerator top and bottom by the radical in the bottom. So that's monomial. These down here are binomial, two terms, and we will talk about that in a minute. So to get rid of a radical, you have to multiply it by the same number if it's square root. And we're only going to do square roots here. But if it was a cube root, I'd have to multiply it 3 times. So every 3, 1 comes out. So I have to get rid of the square root of 5. I have to get that radical of 5 out of the bottom, the whole radical. When you multiply by the square root of 5, you get the square root of 25. 5 times 5, 25. And we know the square root of 25 is 5. So that gets rid of the radical. But you can't just do that to the bottom. You also have to do that to the top. So I'm going to multiply the top and the bottom by the square root of 5. So on the top, you cannot multiply a number outside the radical and a number inside the radical. So it'll just say 3 square root of 5. And on the bottom, number outside the radical, and then the 2 numbers inside the radical. And then we have 3 square root of 5. Then we know the square root of 25 is 5, or every 2, 1 comes out. And that 5 and the 2 are going to multiply. So 5 times 2 gives me 10. And then the last thing you need to check is anything I can simplify. 3 and 10, can I simplify that? No? That's your answer. 8 over 15 doesn't simplify at all. We're trying to get this radical out of the denominator because this is saying the square root of 8 over the square root of 15 from our dividing rule up there. So I'm going to multiply the top and the bottom by 1. And why I say 1 is because multiplying by any number on top and bottom is just like multiplying by 1. Officially offline. That doesn't help us. Go away. Multiply, they're both in the radicals, so we can multiply the radicals. Square root of 15 times square root of 15 is a big number. I don't know what it is. I can get my calculator and multiply them, but I don't know the point because every 2, 1 comes out. So I'm not going to multiply those numbers. You can, but then you'll have to break it all down anyway. So really, what's the point? 8 times 15, still the same thing. I can multiply those 2 numbers together, but then I'm going to have to simplify it. So what's the point? 8 is 2 times 4, and 2 times 2, and 15 is 3 times 5. All right, and then we're going to simplify both of them. So square root of 15 times square root of 15 is 15. That was the whole reason our radical's out the bottom. And this would be 2 square root, multiply everything that's left over. 2 times 3 is 6, 6 times 5 is 30. Is there anything I can simplify? Because a lot of people will do 30 divided by 15 is 2, so 2 square root of 2. But this isn't 30, this is the square root of 30. That is a different number, and we can't simplify that. And the 2 and the 15, we can't simplify. So that is your answer. So try to divide the numbers outside the radicals and the numbers inside the radicals. Okay, 3 and 4 can't simplify. So we're multiplied by the square root of 7 on top and bottom. So we have 4 square root of 7 times 7. And 3 square root of 12 is 2 times 6. And 2 times 3 is 6. Now we're putting it times 7. Every 2, 1 comes out. So I have, because this is square root, so 2 and 3 will make me 6. 3 times 7, 21. And 4 times 7 is 28. Well, now we got to a part 6 is divisible by 28, so we have to simplify that. 6 and 28 are both even. So I'm simplifying this, 6 over 28. So I'm dividing by 2, 3, and 14. And that doesn't simplify anymore. So 3 cube root 21, square root, over 14. There's your answer. All right, next one. Is 3 divisible by 28? I think so. 28. Is 28 divisible by 3? Okay, no, it's not. All right. A to the 5th over A to the 5. That can reduce. So I'm going to do 28 over square root of 3. 5 A's on top, 1 on bottom. We'll leave 4 on top when I cancel them out. What I mean by that, if I have 5 A's on top and 1 A on bottom, 1 on top and 1 on bottom cancel out, I have 4 left on top. But we still have to rationalize, so we have to multiply the top and the bottom by the square root of 3. Can't leave a radical in the denominator. Square root of 3 times square root of 3 is square root of 9. And the square root of 9 is 3. So that's a waste of time. Let's just go ahead and put 3. I can multiply the 28 and the 3, but then I'll have to just take it away later. So I'm just going to break down 28. 28 is 2 times 14. 14 is 2 times 7. And then we still have that 3 we're multiplying in and 4 A's. Every 2, 1 comes out. 2 times 2 is 4. The square root of 4 is 2. And all my A's come out. I have 2 groups of A's. 7 times 3 is 21. It's all being divided by 3. All right, I did something wrong. Hold on. Let me think. No, I did everything right. 28 times 3 is 84. I just want to make sure I broke this down. 2, 2, 3, 7, 2, 2, 3, 7. Not in the right order, but it works. There's your answer. All right. Square root of 2. This is a little weird. I would break this into 2 questions. And that's what we're going to do. I'd break that into 2 questions because the square root of 8 is being divided by 2, square root of 2. And the square root of 2 is being divided by the square root of 2. Make that into a big fraction. Square root of 8 over 2. 8 divided by 2 is 4, so we have the square root of 4. Square root of 2 over square root of 2 is 1. Any number on top of itself is 1. Is 1. Even if it's square root, it's still 1. And we know the square root of 4 is 2, so 2 minus 1 is 1. Interesting. Same thing here. Break into 2 different 3 square root of 2 over square root of 12. Square root of 6 over the square root of 12. And then rationalize it. Square root of 2 over 12 is the square root of 1 over square root of 6. Square root of 1 is just 1, so that's 3 over square root of 6. And that's 6 divided by 12 is a half, so 1/2. Square root of 1 is 1. We square root of 2. All right, simplified, but we still have to rationalize both of those. So to rationalize both of those, I multiply. We'll do this one first. Square root of 2 on top and bottom. So I get the square root of 2 over the square root of 4, and square root of 4 is 2. Multiplied by the square root of 6 on top and bottom. Can't do anything here. One's outside the radical, one's inside. And the square root of 36 is 6. And then 3 and 6 simplified to 1/2. 3 and 6 simplified to 1/2. 1 over 2. So the square root of 6. You can have a 1 in front. There's always a 1 in front, though. Plus square root of 2 over 2. Radicals out of the denominator. That's your answer. That's an ugly answer, but it is. Okay, now we're at a binomial denominators. Multiply the numerator and denominator by the conjugate. I can't say this word right now. Conjugate. The same expression, but with the opposite sign in the middle. So the conjugate. So the conjugate of 4 plus the square root of 2 is 4 minus the square root of 2. Opposite sign in the middle. When I do the bottom, I have to do the top. And then make sure you distribute correctly. Distributing the top's pretty easy. 4 times 4 is 16. 4 times the square root of negative 2. The 4 and the 2 can't multiply because the 2's on the inside. So the 4 gets multiplied to the 1. And then you have the square root of 2 at the end. So that's the top. The bottom is more difficult because you have to FOIL. Distribute every number to every number. So the 4 has to get multiplied to the 2 numbers. And if you notice, it's the exact same thing I did on the top. And then the square root of 2 has to get multiplied to both numbers. So square root of 2 times 4 is 4 square root of 2. And square root of 2 times square root of 2 is the square root of 4 with a negative in the front. That's very ugly, but since it is the conjugate, the purpose of the conjugate is that it's going to simplify to just a nice number. So negative 4 square root of 2, positive 4 square root of 2, cancel out, give you 0. The square root of 4 is 2, so minus 2. And 16 minus 2 is 14. It's an ugly line. 14. So 16 minus 4 square root 2. The hardest part about this is simplifying it because all of these numbers are even, so we have to simplify it. The answer will say leave it in simplest form, or the question will say leave it in simplest form. So 16, 4, and 14 are all divisible by 2. So I'm going to divide all those by 2. I don't divide into the radical because that's a different number. So 7. 8 minus 2 square root 2. And that's it. A long, complicated way of seeing that is I take a 2 from the top, and then 14 and 2 becomes 1 and 7. But it's easier just to think I have to divide everything by 2. All right, these are the hard ones. Let's do another one. I'm going to foil a little slower this time. I was just trying to get to the point of when you multiply by the conjugate, it simplifies to a nice number. So that's why we multiply with conjugate. So this is a binomial, 2 terms. The conjugate is 6 plus the square root of 5 on top and bottom. Distributing on top's easier. So 12 plus 2 square root of 5. And then on the bottom is a little harder. We'll do colorful. So 6 times 6. 6 to the 6 is 36. 6 to the square root of 5 is positive 6 square root 5. The 6 is outside the radical, the 5 is inside, so we can't multiply those together. So the 6 just sits in front. It's negative square root of 5 times 6. Negative 6 square root 5. 6 outside the radical, the 5's in. Can't multiply those together. And lastly, negative 5 square root of 5 times negative square root 5. They're both inside the radical, so you can multiply them and get negative 25. Square root of 25. All right, simplify. Square root of cancel. One's positive, one's negative. That gives you 0. Square root of 25 we know is 5. So 36 minus 5 is 31. 12 plus 2 square root 5. This is odd. 2 doesn't go into 31, so we can stop there. That's your answer. Pause it if you need time copying it down. I'm going to keep going. Got 4 more of these. If you're done and you understand it, you can stop watching the video. I'm not taking your notes up. These are just to help you. Multiply by the conjugate, 1 plus 4 square root of 2. This is a good one to see because it has a number outside the radical and a number inside the radical. 1 plus 4 square root of 2. Now it's not as easy because this is in the radical, so be very careful. Square root of 3 times 1 is 1 square root of 3. Square root of 3 times 4 square root of 2. Square root of 3 times 4 square root of 2. So the 3 and the 2 are in the radical, so that'll give you square root of 6. The 4 is outside, so it's 4 square root of 6. All right. And then the hard part. 1 times 1. Not hard. 1. 1 times 4 square root of 3. 4 square root of, not 3, 2. Negative square root of 4 over 2 times 1. Negative 4 square root of 2. And then the last one is the hardest. Negative 4 square root of 2 times positive 4 square root of 2 will be negative 16 square root of 4. 4s are on the outside, the 2s are on the inside. 4 times 4 is negative 16. Square root of 2 times square root of 2 is square root of 4. So that's what I did. All right. Positive, negative, cancel out. 1 square root of 3 plus 4 square root of 3. You can't add those because one's a 3 under the radical, one's a 6. They're not like terms. So we're just going to leave it square root of 3 plus 4 square root of 3 on top. And on bottom you have 1. The square root of 4 is 2. So 16 times 2 is 32. And 1 minus 32 is negative 31. That's your answer. Radicals out of the denominator. Can't simplify it anymore. Wait, I changed something. That should have been a 6. Because otherwise I could have simplified it more. All right. Crazy looking thing. Can't simplify anything. Multiply it by the square root of the conjugate of the denominator. That's a 3. And now you're going to have to FOIL on top and on bottom. Makes that real complicated. Okay, so 5 times the square root of 5 is 5 square root 5. 5 times the square root of negative 3 is negative 5 square root 3. The 5's on the outside, the 3's on the inside. Can't multiply them. Continue working. Square root of 5 times square root of 5 is negative square root of 25. Negative times negative is a positive. Square root of 5 times square root of 3 is square root of 15. No idea how we're going to simplify that in a minute, but we will. All right, on the bottom, square root of 5 goes to both. Square root of 5 times square root of 5 is square root of 25. Square root of 5 times square root of negative 3 is negative 15. They're both under a radical. You can multiply them. Then the inside, square root of 3 times square root of 5 is positive square root of 15. Square root of 3 times negative square root of 3 is negative square root of 9. And we'll simplify. 5 square root of 5 can't simplify. 5 square root of 3 can't simplify. Square root of 25 we know is 5, so minus 5. And square root of 15 just breaks down to 3 and 5. There's no groups of 2, so that's it. It's as much as we can simplify on the top. Doesn't look simplified at all to me, but it is. See if we can combine any like terms. The square root of 5, the square root of 3, the square root of 15. None of those are like. They all would have to be the same radical and the same radicand. So they're all square root, but radicand, the number underneath, are not the same. Simplify the bottom. Negative square root of 15, positive square root of 15 is 0. Those cancel out. Square root of 25 is 5. And the square root of 9 is 3. So 5 minus 3 gives me 2. The radicals outside the denominator, you are done. That is probably the hardest you will ever see it. I can't circle this answer, but there you go. I'm going to leave the last two in case somebody has a question and wants to work one of them on our own. Just let me know and we can work this.